So we'll see how the basically circular queue is implemented. Yes,
Can you explain that example?
I'll just write with the uh, standard input output and then we proceed. So we'll go for okay, and then here I define say max as some 10. Okay, so that is my size of queue. I'll declare here the struct. So I named that struct as queue, and then I say here array of max, and we have two pointers or two indicators, rear and front, to point out those values. Okay, and then I named it as, let's say, q. So this is already we well known it. Now we'll define here some functions, so like initialize queue, empty, full, insert queue, delete queue, and print. So here we'll write a void function to initialize the queue. So we'll write here void init, and then you're passing basically here the queue. So we are passing here queue. Next is, we want to check whether the queue is empty or not when we go for delete operation. So there will be an empty function for that, and then we'll define here we are passing basically the structure queue. So I'll name it as p. Then we are checking whether queue is full or not. So for that, we are writing here function full. We are passing here queue as a structure. Then we have to go for delete queue, insert queue, and display queue. So when we go for insert queue, so we are passing here two values. So for insert queue, we are passing here basically one structure queue and the value which we want to insert inside the queue. Then there is a delete queue function. So here delete queue, let's say return the value which you are deleted. So you can say here int delete queue, and then there is basically a queue only, the structure queue, and then we can display the queue. So we are writing here display function, and then we can say here queue start. Okay, is there necessary to write a main function, or should I directly mention only those functions here? Yes. Okay, so I'll directly write those functions. So now let us look at the initialize function. Okay, remember from main, whenever actually you call for those functions, very important point here. See here we are declaring here simple structure. So here I am writing like this in main q, and let's say I'm writing here as kind of small q. And whenever you are passing here, let's say when I call for init function, so I am passing here address of q. Since I am passing here address of q, I am receiving here as a single pointer. Try to understand. But instead of that, if I would have declared here as a kind of structure pointer, then whenever I passing here for init function as address of q, that time I would have received here as a double pointer, because this is the address of pointer I am passing. Address of pointer I am passing from here. Okay. But if you want to go for same programming, and if you're declaring a structure pointer q, you can simply pass only as a init q, because you're passing now simple pointer, and here you will receive as a pointer. Okay. So try to understand that difference here. Okay. So I'll now go for writing the init function. So look at in init function, basically what we are doing here, simply we are basically initializing those values. Okay. So I'll write here init function. So void init. So we are initializing and we are passing here simple q. as a structure. So I'll take here P. And initialize, we are simply setting rear and front as -1. So I'll set here P of rear as -1 and P of front as -1. Okay, this is my init function. Now if I want to check whether Q is empty or not, so for here it is returning some integer value, so we'll write here int empty function, and we are passing here the Q. So if our P of rear is -1, so you can write here if P of rear is -1, that means Q is empty. So this is Q empty, so we return 1, else we will return 0. This is a function for checking whether Q is empty or not. Now the next function here is Q is full or not. Okay, so for this purpose you are writing here int full, and here we will declare here QP. Okay, so we are declaring structure. Now if you look at the condition for a Q is full or not, so it's not like a simple Q. In simple Q generally we write here that max -1, but here the condition is little different, and the condition that we know is if P of rear plus 1 mod max, if this is equal to P of front, okay, then we say the Q is full. That time will return 0, else we will return 1, else we will return 0. Okay, this is very important. P of rear plus 1 mod max. So look at here, if my P of rear is at 4 and the size of Q is 5, so my rear is at 4, my front is at 0, and all the fields are occupied. 3, 2, 1 are all occupied over here. So if I say 4 plus 1 is 5, 5 mod 5 is 0, so 0 is my front value. So that time I can say my Q is full. Okay, so now let's go for the next thing, that is insert Q function. So we'll go for now insert Q. So now in case of insert Q function, we are going basically by using the mod function here. So we have to make sure we incorporate that particular function, the logic in insert Q function. So right here the return type is void. So right here void insert Q. Here I am writing a Q as a structure pointer. So I write here P and the value X which I want to insert in the Q. Okay, so first of all, before going for insert, I have to check my Q should not be empty. So first, if my Q is empty, so if empty Q, so what I'll do, I'll first of all initialize rear and front to 0, and then at 0th position I'll put the value. So what you can do here, we'll set here P of rear is equal to P of front is equal to 0, and then write here P of data of P of rear is equal to X. Else what we can do, simply we increase the rear pointer. So P of rear is equal to P of rear plus 1 mod max. So write P of rear is equal to P of rear plus 1 mod max. So now we have updated the rare, and now here we're supposed to put p of data of p of rare is equal to x. Here completes our insert q function. Okay, so note down this. Now we'll see delete q function here. So for delete q function, before calling a delete q from main function, we have to make sure that q is not empty. So here I'll write a delete q function. So it will return the value which we have been deleting. So the return type here we are writing int, and we are saying here delete q. So here in delete q function, we are passing only a structure q over here. So now here we'll see the x which I want to return, and you can say here x is equal to p of data of p of front. Okay, so that is very important because we are deleting a front element. Then if there is only single element, that means if your front and rear is pointing out to same element, that is means if p of rear is equal to p of front. So in that case what we'll do, we have to simply call for init function which will make p of rear and p of front as -1. Okay, else what we'll do, we'll simply increment the front, and our front will be like p of front will get updated to, so that will update to p of front is equal to p of front plus 1 mod max. Okay, and then we will return x. So this is basically a delete q function. Now let's go for the next function, that is a display function. So it is a little different than the function which we have seen in case of simple q. So I'll take it purposefully here. So in display function, again we have to use the concept of circular queue. I'll check why it is so. So first of all, I'll write the function and then we'll see it case by case. So here void display, and to the function we are passing here a structure q. Now look at here, I need I to traverse the queue. So I will initialize to p of front. So I will start from p of front to p of rear. Okay, so while I is not equal to p of rear, we'll simply print here, print, you can say printf %d p of data of I, because now I is basically here handling the index, so that will be p of data of I, and then I will get incremented modulo wise. I is equal to I plus 1 mod max. Okay, now here once I will point to p of rear, it will not go inside the while loop and it will break. So that means I need to display the last element p of rear also. So here we have to add one more printf statement, printf %d p of data of I, or you can say p of data of p of rare. Okay, anything is okay. Here completes the display function. Okay, now we may have question in the display function why basically we need this modulus. Okay, so I'll take one circular queue concept here. 1 2 3 4 5 and 6. This is 0 1 2 3 4 and 5. Let's say my front is pointing to 4, my rear is pointing to 1. So there is value something like a z x p. So my output should be, it should display output like a z x p. So my I is first of all pointing out to front, so I'll print data of I, so it will print a. Then I will point out to I plus 1 is 5 mod 6, that will be 5. So I will point out to 5, so a of data of I, that is z, so it will print z. Now after 5 I should go to 0, so 5 plus 1 is 6, so I is 6, 6 mod 6 is 0, so now I will be 0, so I'll print here x, data of I is x. Now I plus 1, so 0 plus 1 is 1, 1 mod 6 is 1, but now here my p of rare is also 1, so that time this loop will break, and then I will print here the last I of data of 1, so data of 1 is p, so that will print here p, and here it completes our display function. Okay, so we note down this insert queue, delete queue and display function over here. I'll give 2 minutes.